Hello, this is Mr. Wynn. This is part 3 of the Algebra 2 Semester 1 final exam review. Alright, so now we're at solving radicals. Make sure you get the radical, meaning the thing in the square root sign and whatever's inside by itself. It doesn't matter what's inside, just get the sign by itself. So there's nothing in front, there's nothing right here, and there's nothing behind. So it is by itself. Once you have it by itself, you have to get rid of the root sign by using the correct exponent. I'm going to raise both sides to the power of 2. I'm going to square both sides. The square root and the square power cancel out, so this is just 3x plus 4. And 10 squared is 100. Do not write 20. It's not multiplication, it's the power, it's the exponent. Now we just solve like normal. So subtract 4. We get 3x equals 96, and then divide by 3. X equals 32. Now you should check by plugging that into the original problem and plugging the calculator. So I'll do that. And you'll see that it matches. Make sure both sides match. So square root of 3 times 32 plus 4. That gives me 10 on the left equals 10 on the right. We're good. If they don't match, it's no solution. Here's a slightly harder one. Remember, I want to isolate or get the root radical by itself, meaning that 2 and that 4 need to go. This is like the same thing as this. All right? I would have to add the 4 first, divide by the 2 second. So, I am going to add 4 to both sides. So 2 square root of 4x plus 8 equals 12. I need to divide by 2. Square root of 4x plus 8 equals 6. Now my radical is by itself. Now I can use the correct exponent to get rid of the root. I'm going to square both sides. So 4x plus 8 equals 6 times 6 is 36. I do regular algebra, so I'm going to subtract 8. So 4x equals 28. And last, I'm going to divide. X equals 7. So again, plug in the calculator, or plug into the main problem, use a calculator if you want. And the left side will equal 8, the right side equals 8, we're good. Alright, simplifying. When you see a radical, make sure you break it down, use the tree branch method. So 128 is 2 times 64. 64 is 8 times 8. 8s are both 4, 2, 4, 2. And 4s are 2, 2, 2, 2. Alright, I am finding groups of 5 because our index is 5. If there's no number there, it'd be square root, there'd be 2, finding pairs, but 5 of a kind. So 1, 2, 3, 4, 5. So there's 5. So for each complete group, only one of them makes it out. The rest disappear. Now these two 2's that don't make a group, they have to stay inside the root sign, the 5th root sign. Now if there's more than one number side by side, they multiply. So really the inside is actually 4. So that is the number part. Now I gotta do it for the letters. Now x11, if you want to do the long way, 5, 6, 7, 8, 9, 10, 11. There's 11 x's. 5, 6, 7, 8, 9, 10, 11. I'd circle groups of 5. So 3, 4, 5. 1, 2, 3, 4, 5. There's 2 complete groups. One makes it out, the rest disappear. One makes it out, the rest disappear. So 2 x's make it out. So x times x is x squared. That single x stays inside. Now, instead of writing it all out, we can just find how many groups of 5 are there. So I'd actually do like this. There's a complete group of 5, another complete group of 5, and one left over. So for each complete group, one makes it out. So 2 make it out, and that's x to the 1 stays inside. So when I try the y7, you could write all 7 y's out in circle 5, or you can say it was one complete group of 5 and 2 left over. So for this group, 1 makes it out, and that y2 stays inside. And we have that last one. It says Z3. Well, there's not even 5 of them, so they stay inside. They don't get out. So this is my answer. Here's another one, slightly harder. Break it down. 2 times 243. 243 is 3 times 81. 9 and 9. 3 and 3. 3 and 3. So there are 5 3s and 1 2. Let me put that 2 a little closer. All right, we're finding groups of 5, so that makes a group. Only one that makes it out. The rest disappear. And that 2 has to stay inside. All right, now for the letters. A18. Well, there's 3 complete groups because 5, 10, 15. So A5, 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 A3. So 3 complete groups mean 3 A's make it out. A cubed comes out. That A3 has to stay inside because it was not a complete group. All right, B12, well, 5, 10, 2 complete groups and 2 left over. So 2 make it out. 2 stay inside. And C4, there's not even 5 of them, so they stay inside. They can't move. All right, find the inverse of the following. So to find the inverse, remember we were flipping. You have to change the x's and the y's, same for domain and range. So this is originally y equals negative square root of x. Well, I need to get the square root. Well, let's flip it. So we're going to change the problem to x equals negative square root of y. We need to solve for y getting it by itself. So like before, I want to isolate the radical. I need to get rid of that negative sign. So I'm going to divide by negative 1. So now I have negative x equals square root of y. Once the square root is by itself, you're going to square both sides to get rid of the square root. Negative x times negative x is positive x squared. Square root y squared is y. So here's my answer. Y equals x squared. Now that's a parabola. Now that's only half the answer. I said be careful with the new restricted domain. So what I mean is this. Our original picture, meaning this thing right here, is a square root that's flipped. So I start 0, 0, and I flip it. Looks like that. Now our final answer, the invert, it's a parabola, y equals x squared, meaning it looks like this. When we change, or when we invert something, it shouldn't grow on the side, because it looks like half of you turns to a full you. Remember, it's a reflection over this line. So one of those pieces should not exist, meaning this thing shouldn't exist. We only want the left side of the parabola, because that's the true reflection. So to do this problem, I'd actually do the domain and range. Notice the domain of that new line of this y equals x squared. We only want the part that's negative infinity to 0. And that would be the original range of that black one, because this black line, that range it goes down forever, it goes up to 0. So like before, like the very first video, find the domain and range, flip it. We only want the left side, the negative infinity to 0 domain part, and then make sure you can do the calculation. Just flip x and y, solve for y. You probably have to square, use the correct exponent. Find only the real root. Remember, root is a x-intercept. And for this, instead of showing you by hand, I'll just tell you use a calculator. So in the calculator, f of x, same thing as y. So you just type it, x cubed minus 2x squared plus 5x minus 10. So we're looking for the real root, the x-intercept. So it's a nice number. It looks like it goes to 2. If you're not sure, you just click trace and you type the number you think. I think it was 2. And it says when x is 2, y is 0. So my answer here is x equals 2. Or you could just say 2, 0. Now, if you want, you could also do second graph to see the table, and you see where the y is 0. Not x, but y. It's where x is 2. All right, same thing here. Find the real root. Again, use the calculator. So graph it, negative x cubed plus 4x squared minus 3x plus 12. Find where it crosses the x-axis. What would I do? Negative 3x cubed plus 4x. Okay. Right there. It looks like it's a 4. I'm going to check. Trace 4. 4, 0. Good. Or second graph, I see a table. At 4, y is 0. So x equals 4. So free problem, just use a calculator. You don't need to show any work. Identify equations or inequalities in a graph. So this green line is dotted and it's constant. It's horizontal, that's a y. So y, that's 1, 2, 3, 4, 5, it's 5. Now since it's dotted, you can't do the equal sign. It's either less than or greater than. Now if y is on the left side by itself, which in this case it is, you can use a shortcut. If you shade below the graph, it's always less than. If you shade above the graph, it's always greater than. You could do the test point if you want. For example, it's shaded at the bottom, 0, 0 works. 0 is smaller than 5, that's true. Alright, so that's the first line. For the blue line, instead of starting at 0, 0, it goes, or starts up 2. It went up 2. Alright, and its diagonal has x. We need the slope. So pick 2 points. I'm going to use this point and this point. Notice it went up 1 over 2. So my slope is positive 1/2. Up 1 over 2. And you shade above. Above means greater. And that's it. So the constant line is simple. The diagonal line, find the slope, and then find the y-intercept. Remember, y equals mx plus b. Here's another one. This constant line, y equals -4. But it's dotted, and you shade above, so greater than -4. This blue line right here, the y-intercept is -4. It went down 4 instead of 0, 0. And the slope, I'll pick this one and this one. You pick any two. Notice it went down 1, not down 2, over 1. So -2 x minus 4. It's shaded above the blue line, so it's greater. And it's solid, so equal sign. Alright, factor completely by grouping in the slope formula. So this is kind of new. But grouping means if you have 4 more terms, pair them up. So here's one pair, here's another pair. And factor means GCF. So the first 2 terms, I can take out x cubed. There's no number GCF, but there's a letter GCF. What's left over is a single x plus 4. Now I'm going to do the second part. I can take out a positive 8, but what's left over would be -x minus 4, which is not the same as the original. Because see, the original was positives. So instead of taking out a positive 8, I'll take out a -8. Just change the sign. So -8x divided -8 is positive x. -32 divided -8 is positive 4. Now they have the same thing. Now it looks kind of weird, so let me try this. I'm going to say x cubed, and that parentheses I'm calling y. Minus 8, and that parentheses I'm calling y. Here you could tell me, well, the GCF of these two would be y. So I take out a y, and what's left, if I divide it, it should be x3 minus 8. So that y thing is a parentheses in this case. So I'm going to do the GCF again. So for the first pair, I found the GCF. Second pair, I found GCF. Now this is a brand new pair of 2 things. The GCF is x plus 4. What's left over would be x cubed minus 8. Now that's the grouping part. Now the slope formula, if you ever see x cubed and another number, you're going to take the cube root of both. So if you take the cubed root of x cubed, you break it down, you get 3 x's, 1 makes it out. The other 2 disappear. Then you take the cube root of 8, well that's just 2 times 2 times 2. Found a triple, 1 makes it out. Once you do have that done, now this is actually on the formula chart as the very top cube trinomial, perfect cube. You're going to do the first thing, square it. So x times x is x squared. You're going to multiply those 2 numbers you got. So x times 2 would be 2x. And then that last thing, 2 times 2, 2 squared is 4. SOAP tells you about the signs in the middle. S stands for same sign. O stands for opposite sign, and AP stands for always positive, always plus. So this sign was originally minus, so it's the same, opposite of it, and always positive. And don't forget this first guy. This is the fully factored form. If I distribute that, I would get the original problem. Now that is a lot of work to do, so you always have the back route of going to all the answer choices, find the longest one, and just distribute it. Figure out which one has or gets the original problem back. That would be the answer. Right, and the last one is synthetic division. Make sure in the box put the opposite. There's 4 degrees 3, should be 4 terms. So 1, 3, -4, -12. And then y'all know the process, and I'll end there. Thanks for watching. Good luck on the test.